equals 0 meters per second. All right, so let's use the red here. Okay. Maybe that wasn't the proper red. Okay, it doesn't really matter. That's X. Okay, you can probably figure this one out in your head pretty quickly. Let's put the ending brackets over here. So let's just use algebra. Fun with algebra right now. Subtract 9.32 from both sides. You're going to get minus 4.06 meters per second squared times x equals negative 9.32 meters per second. Okay, great. Now we're going to divide both sides by negative 4.06. When we do that, we're going to get, this is seconds here for our units, x seconds. Now we're going to get, what would we get? We're going to get 2.295. So it's going to be 2.30 if we round it, seconds. All right. Our units are going to come out to the seconds here. You'll see that when you divide these two. So our x, again, get our x in red. Our x is going to be 2.30 seconds. That's how long it's going to take, and it makes sense, between 2 seconds and 3 seconds. That's how long it's going to take to stop. All right, I think I spent a little bit too much time on that one, but it might be worth it to just go slowly through this acceleration or slowing down rate problem, not acceleration, slowing down rate problem, because it's a new thing for us. All right, so the next part of this problem. Let's do the next part. I'm going to move this up a little bit. And yeah, I'll move it down first. Okay, so use the initial speed and the calculated time to determine the average speed and the distance which the puck travels before stopping. All right. Now we can't use our normal, what was it? Our normal, let's stick with red here. We can't use our normal velocity equation here. It won't give us the right answer. We have another equation for velocity, which we can use for average speed as well. And that's just going to be the initial plus the final divided by 2. So for speed, our average speed here, it's going to be the initial speed plus the final speed divided by 2. We're just finding the average speed. Just like an average of anything. The reason why we can't use this is because our initial displacement and our final displacement aren't clear. It doesn't say where they start from and where they end up. And if we try to use the velocity and the times here, it's not going to give us a good, clear picture of what's going on. So we're going to use this as an easier equation. And this one makes sense anyway. Let's use the initial speed. The initial speed for us was 9.32 meters per second. And our final speed is 0. Let's use 3 decimal places, meters per second. And we're going to divide that by 2. And our answer is, what is our answer? 4.66 meters per second. Yay! That's our average speed. Okay, let's look at the last one. The last one is just really a conceptual question. And maybe a little bit of calculation, but not much. So here we are. Let's go down for this one. There it is. It says the position time graph below represents the motion of a basketball coach during the last 16 seconds of an overtime period during the last weekend's game. Okay, use the graph to answer the next several questions. Okay, determine the total distance walked by the coach during these 16 seconds. The total distance. Right. So distance is the total distance traveled. So you start off with 0 position. That's your origin. And anytime you have a change in this position, you're going to be adding that extra change to the overall distance that this guy travels. So even though he goes backwards towards the origin here, he's still going a distance, and we're just keeping track of all the distance. It's kind of like an absolute value of the displacement. So anyway, he goes up here, and after a certain time, 4 seconds, he's gotten to be 8 meters away. Then he stays at 8 meters for a few seconds, and then he comes back closer to the origin, which is 4 meters. And at that point, he's gone 12 meters total. He stays at 12 meters total, and then he goes a little bit farther away. 12 plus another 4 is 16. And then he comes all the way back to the origin from 8 to 0. So you've got 16 so far, and he's going to go another 8 meters. So the total amount of meters that he's traveled is going to be, I'll just add all these up. And let's use a different color again. Let's use midnight. Let's do midnight. Okay, so for 7A, the total distance he's gone 8 meters plus 4 meters plus 4 meters plus 8 meters. All right, this is 24 meters. That's the total distance he's traveled. B, determine the resulting displacement of the coach after these 16 seconds. So he's gone a total displacement of 0 meters. Determine the displacement of the coach after 12 seconds. So where's 12 seconds? 12 seconds is right here. Let's go up a little bit. I would say that he's gone 6 meters. That's what I would say. I forgot to use significant figures for this, of course. What am I thinking? This is going to be 24.00. This is going to be 0.00, and this is going to be 6.00, because when you're adding, these decimal places are important for your significant figures. Okay, D. D is, at what time did the coach have the greatest displacement from his starting position? At what time? Well, these are kind of like various ranges over here. So I'd say from 4 to 6 seconds. 4 to 6 seconds. Oh, I forgot the zeros again. 4.00, 6.00 seconds. And he had another point right there. That's got to be 14 seconds. Right? E. What was the fastest speed at which the coach walked during any of the time intervals for the last 16 seconds? So we're looking for speed here. We're talking about the change in his position over time. So the time interval at which he changed his position the most. So think about what that's going to be. Is that going to be a steep curve, or is that going to be a flat curve? When I say curve, I mean line. So is that going to be a steep line, or is it going to be a flat line? If you do a flat line like this, or like a slower rate, it's going to be like this. Obviously, it's a slower velocity, so you don't travel as much position per unit time if it's more horizontal. So here he doesn't travel any. Here he travels a bit, and at which point is this rate the highest? It's actually this one right here, because it's a speed. It doesn't matter if he's going back towards the origin. It's going to be a negative velocity, but it's still going to be a positive speed. So let's say that that interval from here to here is the fastest. So from 14.00 seconds to 16.00 seconds. That's the fastest. And the final one, what's the average speed of the coach during these 16 seconds? The average speed. So remember what the average speed is? It's a change in the distance, the total distance covered over time, change in time. So the total distance covered, we already answered this one. The first problem is 24.00 meters, 0.00 meters, and the total time was 16 seconds. Let's use the right decimal places. So it's going to be 3 decimal places here, which is 1.5, and we can add that 0 meters per second. 1.5, even though I didn't circle the whole thing. That's the answer. Okay. That's our first problem set. That was a pretty easy problem set. So I hope you didn't need too much help on that, and I hope you've gotten the even number problems fairly easily as well. Next week is going to be vectors, and vectors are kind of tricky. So good luck thinking about that. And I'll be back to help you out with the odd number problems for that problem set as well. All right, ciao.